Hi everyone, I'm Ellie, founder of Code of the Future, and today I'm going to be showing you object-oriented programming in Python. So if you are a beginner, then don't worry, this is where you will learn all of the fundamentals of object-oriented programming in Python. So a little bit of background about where object-oriented programming, or OOP for short, it was actually developed as a way of handling the rapidly increasing in complexity of software systems, and also to make it easier to modify these large and complex systems over time. So that's a little bit of background about where object-oriented programming came from, but for now I'm going to do the usual. I'm going to put my glasses on as usual and I'll move you onto the screen where we can start learning more about object-oriented programming. Okay, perfect. So we are in PyCharm and I'm going to be showing you the fundamentals of object-oriented programming. So one of the first things that I'm going to mention to you is that every value in Python is actually considered an object. Okay, and I'm going to demonstrate what this actually means. So let's say we have a random number, something like this, and let's say we have a random word. Let's say hello. Now, if I print the type of number and we run this Python file, so I'm just going to run because I haven't previously run this, so object-oriented programming. And if I run this Python file, what we notice is it comes up with this down here, and it's saying that the class of number is int. So essentially, this number variable belongs to the class integer. And this is something that we kind of already know. So, you know, if I write here, we'll do, instead of number, we'll also put the type of word, and I run this. Okay, so we have a class of string. Now this is something that if you've touched upon Python before, you'll understand this. You'll think, well, this is intuitive. We have a number here, so therefore it must belong to an integer. Obviously this is an integer, and we have, you know, a string, so it must belong to a string. So what I'll just put here is number is an object of the class int, and word is an object of the class string. So what we have here is we have an object, you know, this is the essence of the video, object-oriented programming. We have objects that belong to specific classes. So this isn't just restricted to things like integers, strings, tuples, booleans, things like that. It also works for functions. So let's create a little bit of a function. So we'll say we can also find the type of a function. So we'll create a very simple function. Let's say definition. Let's define it to be my name, and all it's going to do is it's going to print Ellie, because my name is Ellie. Now what we can do is we can say get Python to print the type of my name. Now this might seem a little bit confusing. You might think, well, why is it that we're doing this? We're getting some syntax errors up here because I don't have two spaces between my functions. Okay, I'll just drop this down. So we have this function, we can print what type it is. So I'm running it. Okay, perfect, there we go. This function belongs to the class function. So my name here, this function that I've created, is an object of the class function, just like number here is an object of the class integer, and word is an object of the class string. So this is giving you a little bit of background about how object-oriented programming works. What it means is we can actually create our own classes with our own objects in, and that's what I'm going to show you now. So I'm going to write here in capital letters, we can create our own classes. How cool is that? Can't spell today, there we go. How cool is that? Okay, perfect. So before we go on to create our own class, I'm just going to show you how it works with Turtle. So if you haven't used Turtle before, it's essentially a drawing package that comes with Python. It's really, really cool. If you haven't already done anything in Turtle, then I'd recommend having a look at it. There are a few videos on my channel, so check them out if you're interested. But I'm going to show you how it works for a specific module. So what I'm going to say is every time you create something in Python, and so I'm writing all this out just so that when it comes to refreshing your memory, you'll remember what it was that we're explaining. So every time you create something in Python, you are creating an object that belongs to a class, just like I've shown you. This class defines the things that the specific object can do. So what that means is, so with the function, I'll just drop this down just because, yeah. So with the function, my name, what that's saying is because it belongs to the class function, that essentially means it has all of the, you know, ability of what a function would have, just like an integer has the functionality of an integer. I'll just drop this down just so we can see what we're writing. Okay, now the next thing I'm going to say is I'm just going to split this up because I don't want to write too much text because it may be a bit much for you to read. What I'm going to say is specifically an object has a state, I'll put this in capital letters, and a collection of methods it can do. And don't worry if this seems a bit confusing, I'll explain it when we go on to an example. So specifically an object has a state and a collection of methods that it can do, / perform. The state is the things the object knows about itself. So we're going to do a bit of an example using turtle. Okay, so we're just going to import turtle into my laptop, into this Python file, and we're going to say the turtle's position, colour, etc. is the state. So we can say turtle.colour, make it red, and this here is the state. This is what the turtle knows about itself. It's similar to the position. This isn't what it knows about itself, it is going to that specific area. That is what the turtle knows about itself. So here we have, this is the state. Then we have the turtle's movements. So forward, backwards, left, right are the methods. So if we say turtle.forward, I don't know, 1,000, maybe not 1,000, we'll do 100. This here, this is the method, because this is what it can perform. It can move to a certain area, it can go forward, it can go left, it can go right. That is what is known as the method. So what we can do is we can create our very own class with methods, and it's actually not too complicated, and this is where object-oriented programming comes in. So what we do is we begin by creating a class, and the way that you do that is write class, and you can create the class whatever you want. So we're going to say dog. This is the typical example that is used throughout a lot of object-oriented programming because it is so easy to get your head around. I will be doing other examples with a bit of maths and just a few other things that may help you understand it in a more complicated way, just to show you more complicated versions, but I'm sticking with the dog and animals in this video because I don't want to overcomplicate you. So you start by writing class, and then whatever it is that your class is, typically with a capital letter and a colon at the end. Now we can press enter, and I'm just going to put some words in here just to explain what's going on. So within this class we can define the methods / operations that our class will do. And specifically, a method is just a function that goes inside our class. I would say we'll just put essentially there, just because this is essentially what it is. That's not a very specific definition, it's just something that's very easy to remember. So I'm gonna maybe just take this hashtag outside of the class, just so you can see what's going on. Okay, so we've got our class and it's dog, and what we're going to do inside this class is we're going to say let's define a function. So let's put def or define. We're going to say the colour, so we're defining the function to be colour, and notice that as soon as I put brackets, so I go like that, literally just the first bracket, it automatically indents and it automatically writes this self. Now what's worth mentioning is all functions and all methods in a class will always have this self function here. So that's the only difference. This is the difference between a method and a function outside of a class, is that you have this self parameter in here. So that's really something important to remember. Make sure you always have the self in your method. So def color self, I'm just going to say the color is, so let's say return, let's say brown. Let's say we've got brown Labrador. Perfect. So that's just our class dog. We've got a function inside, so we've got a method inside. Just press an enter in there just to make it look a bit neater. So we've created this method here. We've got our color. So what we can do now is we can create a variable of this class that we have. So I'm going to say now we can create a variable of our class dog. And the way that you do that is you create a variable as normal, you make it equal to the class with open brackets, and then all you want to do is you want to print X. And I'm just going to show you what this will do. And we'll click run, but just before I do that, I'm just going to hashtag out these turtle commands in here because I realised that it will go off the screen and do the turtle commands if I'm not careful. So we'll click run, and notice here we've got this that pops up. So these were what we printed before, and we have this down here. So we've printed X, and X is the variable of our class. So what we have, this here, this main here, is essentially the module that the class was defined in, and it's default set to main. So this is default, but essentially what we've done here is we have created our own class. This is saying we have our own class, which is incredible. We've created a very, very simple class, and I'll go on to show you how we can make it even more interesting now. So I'm just going to write here the main is the module that the class was defined in, and this is set by default to main. So we have created our very first class. How cool is that? We've done it. Now I'm going to show you, how you can make it a little bit more interesting. So now we've created our very own simple version of a class. We can make it more interesting by showing you the initializer. So now we can explore something known as the initializer. Now the reason you probably initializer. Now you're probably wondering, I probably put a Z there because it's American spelling. You're probably wondering why I'm writing so many comments, but it's just because I know a lot of people have said that when I write comments it makes them understand it a lot better, and also it means that I'm kind of pausing for a breather while I do write, so that it's not coding the whole time. It's just helping you understand it a little bit better. But if you don't enjoy it, then comment down below and I'll make sure I improve it for my next video. So now we can explore something known as the initializer. This is something every class should have, and that's just something worth remembering. It essentially sets the default parameters for our class. So it's similar to how a turtle has its own default settings. So the initializer is essentially just setting defaults for your class, and it's really, really helpful. It's especially helpful when you go to do simulations and maths, if you ever do that in coding. I found that when I went to do my dissertation, part of my maths degree, I used Python, and it just helped set some default parameters, certain numbers that would really help. So I will explain how this initializer works, and I'll say we will set up a new class to demonstrate the initializer. Put a Z because it's American spelling. So what I'm going to do is I'm going to create a new class, and I'm going to call it dogs this time instead of dog, and we're going to write def, so it's a function again, and you're going to write this, so __ init sounds very British, init __, and inside that you will have self. It automatically does that. So this is what is known as the initializer. So inside here you can write things like self dot, let's think of an animal, a dog. We'll say Labrador. I'm going to let that equal to 2. So let's say we have 2 Labradors, and then we'll say self dot, what are the dogs? Let's say poodle. Let's say we've got 3 poodles. Okay, so you might be thinking, what's really going on here? So we've set up this initializer method. We have self, which is what every parameter, you always need to have this parameter in your methods and in your initializer. So what this is saying here is we have 2 Labradors and we have 3 poodles. Now we're going to create the variable again of this class dogs. So define a variable of this class, and this will, what this does is it creates an instance of the class. So let's say A will equal dogs. So we set this variable to be dogs. Now what's really cool with this variable, it's similar to how turtle works, and I'll show you how it works. So if we say a and we say dot, notice that the two kind of predicted things for us to write are poodle and Labrador, and that's because we have put self dot poodle and Labrador. So if I was to write a dot, let's say Labrador, and I was to print this, we click run, notice it comes up with 2. So this is how methods work. Essentially with this initializer, when you put self dot and say Labrador and you assign that to a variable, you can then recall it as a variable later. So a dot Labrador gives us 2, and you know, I bet if we were to put a dot poodle, we would also get 3. So there we go, we get 2 and 3. So that's really, really cool. You can make this a string. It doesn't have to be, you know, numbers. It could be, his name is, let's call it Barney. I'm not really sure if that's a typical dog's name, but it's the first name that popped into my head. Click run, there we go, Barney pops up. So this initializer method is really, really handy because it means that you can set some default parameters into the system and then use those parameters later, which is what I'll show you in a minute. But just for now, it's really cool to show you, you know, how this works. It's similar to how you put turtle.color, and you can, you know, set the color, or you can see what the color is. And I just think it's really, really cool. So what this has done here, this is showing our method in action. Now what's really worth remembering is 2 instances of the class are not always the same. And what I mean by that is if I was to create another variable b and make that equal to dogs again, just like I did with a, and then I said print a equal to b, so is, you know, are a and b identical, and I click run, we have false. So it's, you know, it's always worth remembering that two instances of the class are not always the same. So this here, this is false. So now we've seen how you can set up an initializer and methods. I'm going to show you some extra features that you can add. So let's look at the extra features you can add. So let's create a new class. We'll call it animals. Remember, capital letter and a colon, and we're going to set up the initializer. So I'll just put initializer, remembering with the Z, because I'm not American, but it'll put a line underneath it if not. We're going to define it as before, so init, it's going to have self. Now what's cool is you can actually put certain parameters in here. So what this means is when you go to call this specific class, it will come up with prompts, and whatever you put in here you will also have to put in there. So I'm just going to show you what this means. That seems a little bit confusing, but I'll show you how it works with an example. So we'll say self, and also in here I'm going to say the animal type, we'll say animal age, and name. Okay, we're going to say self dot type, so this is the animal type, that's going to equal animal type, what we have defined. Self dot, what did we have? We had age, so self dot age is going to equal animal age. I'm just going to put in here animal name, just so we don't write the same thing. Then self dot name is animal name. Okay, so you may be thinking, what's going on here? We're creating a self dot like we did previously with the Labrador and the poodle. So when you go to recall animals, let's say create a variable of animals, and you put the dot, you will have these options, so name, age and type, and all we're doing is we're setting them equal to whatever we input into our initializer, and you can choose to input those specific things. So I'm going to show you what that means. So I'm going to just go on to another line, and I'm going to write, let's say, let's create a new, so let's just create a new variable and let it equal to, did we have A? I think we had, we'll do C because we did A and B. We're going to let that equal to the class animals. Now when I open my bracket, notice here it pops up with this little prompt. It says you need to write in the animal type, the animal age and the animal name. So this is your chance to input your specific numbers, letters, whatever it may be. So let's say the animal type, we'll call it, let's say a dog again. Let's say the animal age is, let's say 10. And let's say the animal name is Barney again. That's not Barney, there we go, Barney. So when you go to create this new variable, and we'll click run. Okay, nothing happens because we haven't asked it to print anything or do anything. watch what happens if I was to create a new variable without adding in these parameters that we've defined here, these within this initializer. So empty bracket, we'll open it up. Okay, we have an error. It says missing 3 required positional arguments. So this is something to bear in mind, is if you have this initializer if we have this initializer and you input your own parameters in here, you will then have to input them when you go to create a variable of that specific class. So we'll just put, it's important to add the specific parameters. And all that means is you just need to define your animal type, your age, and your name. Okay, so we'll just add that there. So we have this animal type, animal age, animal name. What we can do is we can create methods to, play around with those things that we've inputted. So what I'm going to do is we're going to create a method. So let's create a method. So I'm going to create a method and we're going to say def. We'll call it type of animal. Okay, and all we're going to say in here, return. And we're going to do a little string. We're going to say this animal is A. We're just going to do formatting. So if you're unfamiliar with how formatting works, if you put dot format and then we'll say self dot type. Okay, so what this is doing, and I'll explain it. So I'll just explain what this is doing. So self dot type is going to take this here, so self dot type, so that's our animal age, that's our animal type, and because we've done dot format, whatever this is here, it will go into these squiggly brackets here. So now if I was to go, okay, c dot type of animal, okay, and I was to print this, watch what happens. We'll click run. Okay, there we go. It says this animal is a dog, and that's because we've defined here the variable of our class, so animals, is a dog, and all we're going to say is, and all this is doing is it's returning this method. So this animal is A, and self.type, which is the animal type. That's what you input into your initializer, and that's what you see here. So dog. Cool. So let's do a couple more methods. Let's say define, what do we have? So age of animal, literally the same as what we've just done above. We'll say return the age is, we'll do dot format self dot age. So it's really important that you keep this self dot age. If you were to simply just put age, or what do we have, let's say animal age, it won't work. We have an error. It doesn't register that animal age is up here. You need to put self dot age. Okay, cool. So let's copy and paste that, and I'm going to do a final one for the final, what do we have, animal name. So the name of the animal is, and I'll just put self dot name, and we'll just change that to name of animal. So now when I say, okay, well let's print, I'm just going to copy and paste this, let's print the name of the animal, let's print the age of the animal and the type of the animal. So when I run this, there we go, we have the animal is a dog, the name of the animal is Barney, and the age is 10. Amazing. How cool is that? So what we've done is we've created our own methods in this class, and I honestly just think it's so cool. It just shows how easy it is to input certain things and then for Python to return it back to you. I honestly love object-oriented programming. You kind of sit there and think, wow, that is very nice and very neat. So yeah, it's very cool. So we've got these things here. We can also, you don't just have to stick to simple things like, oh yeah, let's just return the type of the animal. You could do something completely strange and say, well, let's just call it a number. This new method is a number, and let's say we want to return, let's say we want to say the age of the animal, so self.age, and we want to add, let's say 100 onto it. So now if I was to print c dot, and let's go number, and we run this, amazing, we've got 110 because it's taken the 10 that we've put in here and it's added 100 onto it. So you can see why this is very helpful with simulations and maths, because all it means is you could basically have a specific formula that works, input it into this into these methods. And I'm going to show you an example of how that works with X and Y coordinates in another video, so if you're interested in that, check that video out. But you can see how you can take, you know, a certain formula, input it into a class, and then all you need to do is input your own numbers and it will literally calculate for different numbers, and it does it very, very fast as well. So yeah, very cool. So I'm just going to say here, you can also do some abstract things. Awesome. So obviously that creates the new variable. We've got this here, animal, and also, you know, it's worth mentioning that I can make a new one. So we can say D is animals. We'll have, let's say, a cat. Let's say the cat's 9, and let's say the cat's called Muffin. Okay, so now let's say I was to take, let's say, okay, we'll change this C to a D, change this C to a D here, we'll run it. Amazing, we've got the animal is a dog because we've still got C is the type and C is the name of the animal, so we've got Barney. But then when we go D, which is the cat version, we have age of the animal and the number, so age is 9 and the number is 100 plus 9, 109. How awesome is that? Cool. So this is a very, I'd say, simple example of how classes work, but it's just so cool. I really enjoy teaching people how to do object-oriented programming because it allows you to, you know, step that a little bit further into Python, gain that intermediate experience, and with this it just means your code will be so much faster and so much neater and a lot nicer as well. So yeah, that is, you know, to begin with, we've shown you how pretty much everything in Python is considered an object and how those objects belong to classes, which is cool, literally everything in Python. We've then, you know, shown you the example with Turtle and how it has methods and states, and then we've taken our own class example. This is without an initializer, and just shown you that we've created a very own class, a very simple class. Then we've gone on to create an initializer, very, very simple, without any extra parameters. So this is without any parameters. We've shown that 2 instances of the same class are not always the same. That's really important to remember. And then finally, we've gone into a little bit more depth and shown you how you can input your own parameters into this class and get it to do some pretty crazy things. So that has been the video today. I hope you enjoyed it. If you did, then please like, subscribe and comment, and I'll be releasing another video explaining how object-oriented programming works in a math sense. So don't worry if you don't have, you know, major maths background. It's very simple, adding, subtracting, dividing, and then a couple of formulas as well. So if you're interested in learning how object-oriented programming works aside from just animals, then check out that video on my channel. But for now, I will see you all in the next video.